Converting between radians and degrees. 1 degree equals pi over 180 radians, or to convert from degrees to radians, multiply by pi radians divided by 180 degrees. 1 radian equals 180 divided by pi degrees, or to convert from radians to degrees, multiply by 180 degrees divided by pi radians. Example 6. Convert pi over 6 radians to degrees. Since we are given a problem in radians and we want degrees, we multiply by 180 degrees divided by pi. Remember, radians are a unitless measure, so we don't need to write radians. Pi divided by 6 radians equals pi divided by 6 multiplied by 180 degrees divided by pi equals 30 degrees. Example 7. Convert 15 degrees to radians. In this example, we start with degrees and want radians, so we use the other conversion. Pi divided by 180 degrees so that the degree units cancel and we are left with the unitless measure of radians. 15 degrees equals 15 degrees multiplied by pi divided by 180 degrees equals pi divided by 12. Just as we listed all the common angles and degrees on a circle, we should also list the corresponding radian values for the common measures of a circle corresponding to degree multiples of 30, 45, 60, and 90 degrees. As with the degree measurements, it would be advisable to commit these to memory. We can work with the radian measures of an angle the same way we work with degrees. Example 8. Find an angle beta that is coterminal with 19 pi divided by 4, where 0 is less than or equal to beta less than 2 pi. When working in degrees, we found coterminal angles by adding or subtracting 360 degrees, a full rotation circle. Likewise, in radians, we can find coterminal angles by adding or subtracting full rotations of 2 pi radians. 19 pi divided by 4 minus 2 pi equals 19 pi divided by 4 minus 8 pi divided by 4 equals 11 pi divided by 4. The angle 11 pi divided by 4 is coterminal but not less than 2 pi, so we subtract another rotation. 11 pi divided by 4 minus 2 pi equals 11 pi divided by 4 minus 8 pi divided by 4 equals 3 pi divided by 4. The angle 3 pi divided by 4 is coterminal with 19 pi divided by 4. Arc length and area of a sector. Recall that the radian measure of an angle was defined as the ratio of the arc length of a circular arc to the radius of the circle, theta equals s divided by r. From this relationship, we can find arc length along a circle given an angle. Arc length on a circle, the length of an arc, s, along a circle of radius r subtended by angle theta in radians is s equals r theta. Example 9. Mercury orbits the Sun at a distance of approximately 36 million miles. In 1 Earth day, it completes 0.0114 rotation around the Sun. If the orbit was perfectly circular, what distance through space would Mercury travel in 1 Earth day? To begin, we will need to convert the decimal rotation value to a radian measure. Since 1 rotation equals 2 pi radians, 0.0114 rotation equals 2 pi multiplied by 0.0114 equals 0.0716 radians. Combining this with the given radius of 36 million miles, we can find the arc length, s equals 36 multiplied by 0.0716 equals 2.578 million miles traveled through space. In addition to arc length, we can also use angles to find the area of a sector of a circle. A sector is a portion of a circle contained between two lines from the center, like a slice of pizza or pie. Recall that the area of a circle with radius r can be found using the formula a equals pi r squared. If a sector is cut out by an angle of theta measured in radians, then the fraction of full circle that the angle has cut out is theta divided by 2 pi, since 2 pi is 1 full rotation. Thus, the area of the sector would be this fraction of the whole area. Area of sector equals theta divided by 2 pi multiplied by pi r squared equals theta pi r squared divided by 2 pi equals half theta r squared. Area of a sector. The area of a sector of a circle with radius r subtended by an angle theta measured in radians is area of a sector equals half theta r squared. Example 10. An automatic lawn sprinkler sprays a distance of 20 feet while rotating 30 degrees. What is the area of the sector of the grass the sprinkler waters? First, we need to convert the angle measure into radians. Since 30 degrees is one of our common angles, you ideally should already know the equivalent radian measure, but if not, we can convert. 30 degrees equals 30 multiplied by pi divided by 180 equals pi divided by 6 radians. The area of the sector is then area equals half multiplied by pi divided by 6 multiplied by 20 squared equals 104.72 feet squared. Linear and angular velocity. When your car drives down a road, it makes sense to describe its speed in terms of miles per hour or meters per second. These are measures of speed along a line, also called linear velocity. When a point on a circle rotates, we would describe its angular velocity or rotational speed in radians per second, rotations per minute, or degrees per hour. Angular and linear velocity. As a point moves along a circle of radius r, its angular velocity, omega, can be found as the angular rotation theta per unit time t. Omega equals theta divided by t. The linear velocity v of the point can be found as the distance traveled, arc length s per unit time, t. V equals s divided by t. Example 11. A water wheel completes one rotation every 5 seconds. Find the angular velocity in radians per second. The wheel completes one rotation equals 2 pi radians in 5 seconds, so the angular velocity would be omega equals 2 pi divided by 5, which is approximately 1.257 radians per second. Combining the definitions above with the arc length equation, s equals r theta, we can find a relationship between angular and linear velocities. The angular velocity equation can be solved for theta, giving theta equals omega t. Substituting this into the arc length equation gives s equals r theta equals r omega t. Substituting this into the linear velocity equation gives v equals s divided by t equals r omega t divided by t equals r omega. Relationship between linear and angular velocity. When the angular velocity is measured in radians per unit time, linear velocity and angular velocity are related by the equation v equals r theta. Example 12. A bicycle has wheels 28 inches in diameter. A tachometer determines the wheels are rotating at 100 revolutions per minute, RPM. Find the speed the bicycle is traveling down the road. Here we have an angular velocity and need to find the corresponding linear velocity, since the linear speed of the outside of the tires is the speed at which the bicycle travels down the road. We begin by converting from rotations per minute to radians per minute. It can be helpful to utilize the units to make this conversion. 180 rotations divided by minute multiplied by 2 pi radians divided by rotation equals 360 pi radians divided by minute. Using the formula from above along with the radius of the wheels, we can find the linear velocity. V equals 14 inches multiplied by 360 pi radians divided by minute equals 5,040 pi inches divided by minute. You may be wondering why the radians went in this last equation. Remember that radians are a unitless measure, so it is not necessary to include them. Finally, we may wish to convert this linear velocity into a more familiar measurement, like miles per hour. 5,040 pi inches divided by minute multiplied by 1 feet divided by 12 inches multiplied by 1 mile divided by 5,280 feet multiplied by 60 minutes divided by 1 hour equals 14.99 miles per hour.